Hello everyone, how are you all? Welcome to Tejama YouTube channel. In this video, I'm going to give the list of formulae for the chapter Gravitation. Okay, so take a pen and paper and list down all these formulae, and this formula will be helping you for solving the numericals and different 1 mark and 2 mark questions, as well as the derivations. And this list of formulae will help you for your competitive exams like KCET, NEET and JEE. Okay, so first of all, we have the Kepler's laws. In that, the law 1 is law of orbits. Okay, so according to law of orbits, all planets move in elliptical orbit. Okay, in elliptical orbits with the sun situated at any one of the foci. With the sun situated at any one of the foci. So the diagrammatical representation of the solar system or any planet revolving around the sun is represented here. So let me consider this is the, what is this? Here there will be a planet and it will be revolving around the sun in elliptical orbit. So we already know, so ellipse consists of two foci. So the sun is present at any one of the foci, here or here. Okay, now this is the first law of orbits. All planets move in elliptical orbits with the sun situated at one foci of the ellipse. Next, coming to the law of areas. Radius vector sweeps equal area in equal interval of time. Means, so if you consider a, what is that, planet which is moving in what is it, the orbit with some particular velocity, so it covers some area. Let me consider t time. It covers the same area in t time here also. Okay, so this area swept by the same planet in the same time t, for example 1 hour or 2 hours. So this time is 2 hours. So here the area covered is a1. So here also in 2 hours it covers the same area. Okay, in that particular time. So that's why aerial velocity will be same. So area swept by the radius vector in the elliptical orbit will be same. Okay, that is given here. The radius vector sweeps equal area in equal interval of time. That is given by delta A by delta T. Rate of change of area is equal to constant. Next, law of periods or law of time period. The square of time period of revolution of a planet is proportional to the cube of semi-major axis. Okay, here which one is major axis, which one is minor axis? See, this one is minor axis, this one is major axis. Okay, so here they have given semi-major axis. So that is this. Semi-major axis means this length A. So the time period of satellite is given by t. This is the time taken by the satellite or a planet for one complete rotation around the sun. Okay, the time taken by the planet around to move around the sun. Okay, that is t. So here the square of time period of revolution of a planet, is directly proportional to cube of semi-major axis. So this is the first law and second law as well as third law of Kepler's. Next we have Newton's universal law of gravitation, that is F is equal to gm1 m bar square. See, I am not explaining the concepts in depth, I am just giving the list of formulae here. Okay, so that's why I will be moving a little fast. So F is equal to gm1 m bar square. This gives the force between two objects which are having mass, and where r is the distance between their centers. Okay, so here g is called gravitational constant and its value is 6.67 × 10 to the power -11 Newton meter square per kg square. Okay, next we have acceleration due to gravity. So what is acceleration due to gravity? It is the acceleration produced by a object moving in gravitational force. Okay, so on the surface of the earth, acceleration due to gravity is given by gm by r square. Okay, small g is equal to gm by r square. This is the acceleration due to gravity due to some mass capital M. Okay, then above the surface of the earth, if you consider, acceleration due to gravity will be given by gm by r plus h. Here on the surface of the earth we consider the radius of the earth. If you consider above it, you have to consider that height also. Okay, so then gm can be written as small g r square by using this formula. Okay, by using that formula, so if you send this r square this side, you will get small g r square, that is equal to gm, so that we can substitute here. Okay, then after solving that, in the derivation I have explained how we have got this. So acceleration due to gravity above the surface of the earth is also given by this formula. So this you need to we will have to remember both the formulae, because you may expect questions in KCET examination on both the formula as well as in board examinations also. Then below the surface of the earth, acceleration due to gravity is given, for example in a main or at a depth. Okay, in a well, so at a depth, what is the acceleration due to gravity? That is given by small gd is equal to g into 1 minus d by r. Okay, then one more is there. So this is about the satellites. So what is the escape velocity? So this is the minimum velocity with which we need to send an object to space against gravity, so that it will not come back, returns on its own. Okay, so if I consider the rocket here, okay, so we have to send the rocket with minimum velocity. We already know that is 11.2 kilometer per second. It travels 11,200 meters in 1 second. So this is the escape velocity for earth, okay, for a given rocket. So what is the formula for that? So that is square root of gm by 2 into gm by r, and if you solve that, you will get this one also, that is v is equal to square root of 2 gr. In the same manner, we have orbital velocity. So now this is the earth, and a satellite is revolving around the earth in space. Okay, let us consider like that. It will be revolving around the earth in the orbits with a velocity that is given by orbital velocity. Okay, the formula for this is given by square root of gm by r athwa r plus h. Here we have 2, here we don't have 2, that's it, remaining things are same. So here 2 gm by r is there, here just gm by r is there. So h means the satellite is present at a particular height anta consider martivi. So we have to take h. If the satellite is present or revolving around the earth very close to the surface of the earth, then you will get this one also. Okay, then we have time period of satellite, that is t is equal to 2 pi square root of r by g, and there is a derivation also for this. So time period is given by what is that, distance by velocity. Okay, then distance is given by 2 pi r, because these satellites will be revolving in the circular orbits around the earth. So we can say 2 pi r divided by velocity will be orbital velocity. If you substitute the values here, you will get the formula for time period. Okay, so there is a derivation also for that, and I have done it in my videos. You just check it so that you will get an idea. Next, energy of orbiting satellite, that is given by E is equal to kinetic energy plus potential energy, that is equal to minus gmm by 2r. So this is all about the list of formulae for gravitation, dear students. We'll meet you in the next video. Till then, take care, bye bye. If you feel it is useful, please share it to your friends and subscribe. Thank you.